Hey class, this is section 3.2, sketching polynomial functions. So for this section, we need to figure out what end behavior looks like. So that just means as x gets larger, does the graph rise to the right or does it fall to the right? And as you go in the negative direction, does the graph rise to the left or does the graph fall to the left? So let's come up with a quick little rules for you. So if your degree is odd, then it's either going to look like this or it's going to look like this. All right, so that means the leading coefficient, which I'll call a sub n, is positive. That means that the graph is going to fall left, rise right. And if your leading coefficient is negative, then it will rise left and fall right. All right, so in this case, if you were to expand this out, you're going to get a cubic because x times x times x is x cubed. And they're all positive. That's positive, positive, positive. Therefore, we're looking at something like this. The degree is 3, which makes it odd. And the leading coefficient is positive. So that means it's going to fall left and rise right. All right, so let's go ahead and find the zeros. The zeros are, since it's already factored, it makes it a lot easier. This one is 0, the middle one is 7, and the one to the right is -3. That would be the 0 to that factor, the 0 to that factor, and the 0 of that factor. So now we know what the zeros are. 1, 2, 3, 4, 5, 6, 7. So 7 is a 0, -3 is a 0, and 0 is a 0. And like we mentioned before, the graph falls left and rises right, so it's got to go through, through, and through. That's what our function will look like. You can get a more accurate graph if you plug in values like -1, -2 into your function. That'll give you a more exact value to see how high this goes and how low this goes. You can plug in more points if you like, but for the purposes of this section, we just want a sketch. We don't need it to be perfect. All right, this one is similar. Let's check what the degree is. The degree is x squared times x, and then you have a negative leading coefficient. So that's going to be x squared times x squared is x to the 4th. So your leading coefficient is going to be negative x to the 4th. Leading coefficient is -1 because of that negative there. So the degree is 4. So when you have an even degree, your functions are either going to look like this or it's going to look like this. We really don't know how many times it's going to turn in between. We just know that the end behavior is going to rise on both sides or fall on both sides. This happens if the leading coefficient is positive. This happens if the leading coefficient is negative. So clearly our leading coefficient is negative, so it's going to look like this. All right. So let's find our zeros once again. Our zeros are -3, -2, +5. However, this one has multiplicity. This one has multiplicity 2 because the exponent tells you how many times that 0 occurs. It occurs twice. These each have multiplicity 1. So this one would be 1 and 1. So when it's even multiplicity, that means the graph is going to touch and turn at that point. If it's odd multiplicity, then the graph goes straight through the 0. So these were odd multiplicities, so the graph went straight through, straight through, straight through. If this would have been an even multiplicity, the graph would have went touch and turn without going through. It just would have touched and turned. So that's what's going to happen at this point. It's going to touch and turn. So let's go ahead and graph this now, or sketch it. 1, 2, 3, 4, 5. So our zeros are 5, -2, and -3. We already know our graph looks like this because of the negative leading coefficient. So it's going to go through, and then it's going to touch and turn because it's got even multiplicity at 5. So that's what our graph is going to look like, or our sketch. It's going to go through, touch and turn. There you go. So this is a general form, but depending on where the zeros are and the multiplicity, that kind of tells you when to turn, whether to touch and turn, or whether to go through. So in these two zeros, we had to go through because of the multiplicity being odd. Over here, the multiplicity was even, so that's when you touch and turn. All right. This next one, we first need to factor it because it's not factored. Then we can find the zeros and determine what the shape of the graph will look like. Notice that it is degree 3. And the leading coefficient is positive. I keep on putting 1, it should be 0. Leading coefficient is positive 1, which means it's going to look like this. The general shape will look like this. Fall left, rise right. So let's go ahead and factor this. In order to factor it, you want to take out you want to factor by grouping. So let's group the first two terms and take out the GCF, which is x squared. That leaves us with x plus 2. Over here, the GCF is -4, which leaves us with x plus 2. And now, if you factor out the x plus 2, which is a common factor, you'll be left with x squared minus 4. So I factored these two binomials out, and I'm left with x squared minus 4, which is here. And then this is the difference of two squares. So that's going to become x plus 2, x plus 2x minus 2, which can be written as x plus 2 squared, x minus 2. So here you can see we have two zeros. We have -2 and +2, but the multiplicity is 2 for this one and 1 for that one. The exponent tells you what the multiplicity is. So for this 0, we're going to touch and turn. For this 0, we're going to go straight through. So let's go ahead and graph or sketch. So our zeros are 2, -2. And remember, at -2, we're going to touch and turn, and the general shape is going to look like this. Fall left, rise right. So here we have to touch and turn, and then here we have to go through. So there's your graph. Touch and turn, go through. That's a sketch. All right, the last problem is very similar. So let's do the exact same thing. The degree, however, is now 4 because of the exponent tells you what the degree is. The leading coefficient is positive. It's +1. So that means for even degree, positive leading coefficient, that means our graph is going to look like this. The general shape is going to look like a W. So let's find the zeros. Once again, we're going to have to factor by grouping. So if we do that, we're going to get group x cubed, x minus 3. Here we're going to take out a -27, x minus 3. And then we factor out the x minus 3 binomial, and we get x cubed minus 27. This is a difference of two cubes. You may have to recall what the formula looks like. It looks like this. A minus b, times a squared plus a times b plus b squared. So if you're factoring x cubed minus 27, that's going to look like this. which now you can see what your A is and what your B is. So when you plug it into the formula up there, you're going to get x minus 3, x squared plus 3x plus 9. That's what the factor is, or that's what the factorization of x cubed minus 27 becomes. So if we write this out, we're going to have 2 factors of x minus 3. All right, and then for this, we're going to have to do the quadratic formula because that's not going to be factorable. So let me go ahead and do the quadratic formula up here. Negative b plus minus b squared minus 4ac. Actually, that's going to be imaginary solutions because you can already see this is going to be 9 minus 36, which is going to be negative. So you don't even have to do the quadratic formula for this factor. These are just imaginary solutions. So there's only one 0 with multiplicity 2. It's positive 3 multiplicity 2. So now when we go to our graph, one, two, three, 1, 2, 3. Our 0 is here, and it's going to, let's see, it's going to look like a W, which would be, let's see, well, you can see what the y-intercept is. If you plug in 0 for x, that'll help us out a little bit. All these terms are going to cancel. You're going to get 81. So your graph is going to be like way up here. I'm just going to call that 81. And then it's got to go down, and it's gonna look something like this. We don't exactly know where it's going to, hold on, let's do that one more time. We don't exactly know where it's going to kind of turn, but we know that it only crosses the x-axis one time because there's only one 0, and it has to touch and turn because of the even multiplicity. So it's going to look something like this. These problems will be multiple choice, so it'll be the only one that has this kind of shape. And that does it for this section.